How to compare and order fractions. Comparing fractions means you've been given two fractions and being asked to calculate which is the larger or the smaller of the two. And ordering fractions, you may be given three or more fractions and have to order them from smallest to largest or largest to smallest. So to do that, to compare and order fractions, we're going to be talking about how to convert to common denominators, comparing mixed number fractions and ordering more than two fractions. To do this, I like to talk about bronze, silver and gold, like I do with adding and subtracting fractions. So bronze means that's what we're always trying to get our fractions to. In this case, where we have common denominators. What we want to do to be able to compare two fractions is to have common denominators. Once we can do that, we can just look at the two numerators and say which one is the two is larger or smaller. So bronze is where we've been given the common denominator. Silver is where, if you look at 3/5 and 4/10, we actually only need to convert one of the two fractions. And gold is where the two denominators are not factors or multiples of each other, so we'll have to work out a common denominator. All right, so we'll start with bronze. Nice and simple and easy. We've got to compare 1/9 and 4/9. In this case, it's bronze because we've already got a common denominator of 9. So we're being asked, what is the larger fraction, or which is the larger fraction, 1/9 or 4/9? In this case, it's quite simply 4/9. Okay, it's the larger of the two fractions because we've got the larger numerator. I was always told to, with the greater than or less than sign, that it eats the larger number. But some people are taught that it points to the smaller number. So it's up to you, what your preference. Having a look at this one, again, we've got 4/5 and 2/5. It's bronze because we've got the common denominator of 5. So all we need to do is look at the numerators. We've got a 4 and a 2. So 4/5 is the larger of the two fractions. Again, the greater than or less than sign eats the larger fraction, 4/5. Right, moving on to silver. Now this time we've got to work out which is larger, 3/5 or 4/10. Okay, now this is silver because actually if you could look at this denominator, it's a 5. 5 is a factor of 10. 5 goes into 10. 10 is in the 5 times table. So actually we only need to convert one of these two fractions, the 3/5, into its 10th form. Okay, so the easiest way is if I keep the 4/10 as it is, and I need to convert because I know 5 goes into 10, I'm going to do it underneath. And 5, how many 5s in 10? 2. So I'm scaling it up by a factor of 2. So 5 times 2 is 10. Do the same to the bottom as the top. 3 times 2 is 6. So 3/5 is the same as 6/10. Now I'm back to bronze because I've got 6/10 and 4/10. The larger of the two is the 6/10. So again, I use my greater than sign to show it's eating the larger fraction. 6/10 is larger than 4/10. Silver again. So once again, if I compare the denominators, it's not bronze because they're not the common denominator. However, if I look at the 4 and the 12, I know that 4 is a factor of 12. 12 is in the 4 times table. Okay, so I know that I can keep this fraction the same and only convert this one into its 12th form. So once again, I shall write my fraction underneath, 7/12, and I'm going to turn my 3/4 into 12ths. How many 4s in 12? 3. So I'm going to be multiplying the numerator and denominator by 3. 4 times 3 is 12. Do the same to the bottom as the top. 3 times 3 is 9. So 3/4 is equivalent to 9/12. Now I'm back to bronze because I've got common denominator of 12. I've got the 7/12 and 9/12. 9/12 is bigger, is the larger fraction. All right, so now we're going on to gold. So this is where, if I compare my denominators, the 2 does not go into 5, or 5 is not in the 2 times table. So I need to find the lowest common denominator, the lowest number that is in the 2 and the 5 times table. Now often you can do this by multiplying the two denominators together. 2 times 5 is 10. So 2 goes into the 10, is in the 10 times table. So 10 is in the 2 times table and 10 is in the 5 times table. So if you multiply these two denominators together, you can often work out your lowest common multiple. So what I like to do is cross multiplying. So I do it like this. I go 5 times 2 is 10, and 5 times 1 is 5. So I could have actually just put the 10 underneath, said 2 times 5 is 10, 1 times 5 is 5. So I could have worked it out like this. 2 times 5 is 10, 1 times 5 is 5. So 1/2 is the same as 5/10. And again, I need to convert this into its tenths. So I could look at it like this. 5 times 2 is 10. 3 times 2 is 6. So I'm multiplying both of these by 2. But I like the cross multiplying, which I'm going to keep talking about. So I like to go from left to right now. 2 times 5 is 10. 2 times 3 is 6. So 3/5 is the same as, or equivalent to, 6/10. So now that I know 1/2 is 5/10, 3/5 is 6/10, the larger of the two fractions is 6/10, because the numerator is 6 compared to the numerator of 5. So once I've got the common denominator, I'm back to bronze, and now I can only need to compare the two numerators. Let's look at another gold. Now this time, it's 1/2 times a third. So I can tell that my lowest common multiple, my lowest common denominator, which is the lowest common multiple of 2 and 3, is 6. And I can check that by doing 2 times 3 is 6. All right, but I'm going to do the cross multiplying to show you how this works. I go from right to left. 3 times 2 is 6. 3 times 1 is 3. So 1/2 is the same as 3/6. And then I go from left to right. 2 times 3 is 6. 2 times 1 is 2. So 1/3 is equal to 2/6. Now I'm back to bronze because I've got the common denominator of 6. So now I just need to compare the two numerators, 3/6 and 2/6. The larger of the two fractions is 3/6. Now for this one, I'm going to explore it in two different ways. I'm going to do both the lowest common multiple and the cross multiplying. So when I look at 4 and 6, again, it's not bronze because I haven't got common denominators. It's not silver because 4 does not go into 6. So it must be a gold standard where I've got to convert both fractions. So if I look at 4 and 6, what's the lowest number, what's the lowest multiple that 4 and 6 both go into? It's 12. So I can try this by writing 12 fraction as the denominator underneath both of these. Now I can calculate it by saying how many 4's in 12? 3. So I'm multiplying 4 times 3 is 12. So I do the same to the bottom as the top. 3 times 3 is 9. How many 6's in 12? 6 times 2 is 12. So 5 times 2 is 10. So 5/6 is the same as or equal to 10/12. So in this case, we've got 9/12 and 10/12. The larger of the fractions is the 10/12. Common denominator, so I've got back to bronze. And I just compare the numerators. Now with that one, I can explore that in another way as well. I could try my cross multiplying and see if I get the same result. So let's try the cross multiplying. 6 times 4, in this case, is 24. And 6 times 3 is 18. 4 times 6 is 24. 4 times 5 is 20. Which is the larger of the two? We're back to bronze because we've got a common denominator of 24ths. 18 over 24 is larger than, 20 over 24 is larger than 18 over 24. Now if I compare both of these results next to each other, you can actually see that it's exactly the same result because 9/12 is an equivalent fraction to 18 over 24 and 10/12 is the equivalent fraction of 20 over 24. So I could have done it this way where I just worked out what the lowest common multiple is, the lowest number that 4 and 6 both go into, which was 12. Or I could have used my cross multiplying method, which a lot of children that I work with actually just prefer to go straight into, where you cross multiply to turn them into a common multiple, common denominator of 24ths, and then I can work out my numerators using the cross multiplying as well. The benefit of this, of working out the lowest common multiple, is that you work with smaller numbers. Sometimes if you use the cross multiplying, you end up with really large numbers, and it can get a bit trickier to work out if you're working some of these subtractions or additions mentally in your head. but in this case it works for me there, so I prefer cross multiplying. Okay, have a quick look at some mixed numbers. Now in this case, I'm comparing which is larger, 1.5 or 1 2/5. Well, in this case, I could ignore the ones because they're both 1 and something, 1 and something. So I'm not even going to look at the ones because they're not important to me here. All I'm comparing is which is the larger of the two, 1/2 or 2/5. So again, this could say gold because the 2 and the 5, 2 doesn't go into 5. So actually, I can try my cross multiplying. I can work out a lowest common multiple is going to be 10. 2 goes into 10 and 5 goes into 10. And I can use my cross multiplying for this. 5 times 2 is 10. 5 times 1 is 5. So 1/2 is the same as 5/10. 2 times 5 is 10. 2 times 2 is 4. So 2/5 is the same as 4/10. Now if I still have my units of 1 in there, it's still the same thing. That's 1 and 5/10 and 1 and 4/10. I've got the common denominator of 10. So all I need to do is look at my numerators, 5 and 4. And 5/10 is larger than 4/10. Now this one here, which is larger, 2.5 or 3 2/5? Well, I actually don't need to do anything here because it doesn't matter what my fractions are. They're proper fractions, which means the numerator is smaller than the denominator. So all I need to do is look at my units. This is 2 and something, this is 3 and something. Straight away, that must be the larger of the two numbers.